Okay guys, welcome to this video. We're going to be creating this Vellum deflate inflate effect today. So what you're going to want to do is drop down your geometry. I'm going to do a test geometry rubber toy to inflate and deflate. Set the uniform scale to 5 and then drop down a Vellum configure balloon. On the Vellum pressure node, set the stretch stiffness to 100, which is here, and on here, set to 1E plus 10. Tick on the output group and name it pressure. Then drop down a Vellum solver node. Drop down a match size node just here, justify Y min so it's above the ground plane, so like that. On the back on the Vellum solver, tick on ground position and then dive into the Vellum solver. Drop a pop steer seek node. Then drop down a Vellum constraint property. Connect that to that. Make sure to bypass this and then connect that. On the Vellum constraint properties, tick on group and on the drop down click pressure. Tick on stiffness. Set it to 0 and keyframe it. Make sure it's on frame 1. Click on this brain icon in the bottom right of your screen so it stops solving for a second. Go to frame 30 and set the stiffness to 0.1 and keyframe. Then go to frame 60 and set the stiffness to 700 and keyframe that. Turn the bypass off on pop steer seek. Come out of this back into the OBJ geo network. Drop down a grid node and plug it into the third input of the Vellum cloth. Drop down a transform node after the grid node. Set the uniform scale of this grid to 2 and set the Y translate to 10. Go to the first frame and keyframe the Y translate. Go to frame 29 and keyframe 0.1 on the Y translate, and then go one frame ahead and put the Y translate back to 10 and keyframe that. Then dive back into the Vellum solver. On the pop steer seek, the attraction type, set it to points. Then on the SOT path, pick Vellum pressure and accept. Then the match method, point per particle, and tick off particle ID and goal ID. On the force tab here, set the force scale to 0 on frame 30 and keyframe that. Then on frame 60, set the force to 100, keyframe that. Tick on arrival. On frame 30, set the braking scale to 0 and keyframe. And on frame 90, set the braking scale to 5 and keyframe. Come out of the solver and on Vellum solver set the substeps to 3 Dive back into the Vellum solver, on Vellum constraint property, tick on rest length scale, on frame 30, set it to 0 and keyframe. Then on frame 60, set it to 1.5. Alt left click to keyframe, by the way. Then on frame 80, set it to 1 and keyframe. Come out of this view, drop down a Vellum post-process node. Connect that. Just connect the first input. On the subdivision, set it to Catmull clock, and then turn on your little brain to solve the simulation. And it's cooking right now, but I'd suggest setting the simulation length to 100 before cooking. And that's pretty much the tutorial. I hope you enjoyed.